Welcome you all in this course on metric spaces. So, as a student of mathematics, you must have a question in your mind, not only one question but several questions on your mind regarding the course which you are going to take. The first thing is that why are you studying, or why will you study the course of metric spaces? What is the need to study this course? What is the meaning of metric spaces? Okay, so all these things we will cover in this course of metric spaces. Now you know that how we can find the distance between any 2 points. It is very well known that if you are in the plane and you have the coordinate of 2 points in a plane, for example, if you have a point A in a plane whose coordinates is x1, y1, and you have another point B whose coordinates are x2, y2, then you can find the distance between these 2 points by taking the formula, by using the formula square root of x1 minus y1 whole square plus x2 minus y2 whole square. But this is true only in case when you have a plane. Similarly, if you have 2 points in a three-dimensional space, okay, you can also find the distance between these 2 points which you have learned in your course of mathematics in class 10 or class 11. So, I am not going to in detail in that one, but the main thing is that how we can find the distance between two cities. For example, how can you say what is the distance between Delhi and Hyderabad? So, the thing is that if you are putting these two cities on a map or on a plane, then and you know the coordinates of these two cities, and then by using the formula which I mentioned, you can get the distance. But it is really a distance between these two cities? I don't think so. Why? Because if you are traveling by train, then the train will go from here, then this way, then this way, this way, this way, this way, this way. So, you will cover more distance than whatever you are calculating by the coordinate systems. Not only this, if you go by car, then it might be quite different. So, which distance do you want? Which distance you will say that this is the distance from Delhi to Hyderabad or Hyderabad to Delhi? Okay? So, the important thing is that here is the important thing, we define the distance between any 2 points or any two elements. For example, if we say that, I say that, okay, for me the distance between any two cities is the distance covered by the car. For you, it might be a distance between two cities is the distance covered by the train. For the third person, it might be a distance covered by a plane. So, what is the distance covered by a plane? It is called, it is nothing but it is similar to as the one which we have calculated by the coordinate system. So, you have one coordinate here, you have another point is here. So, you treat this is as your Delhi, this is your Hyderabad, and now you have the coordinate system and you can calculate the distance between these 2 points. So, that is the way to calculate the distance between any 2 points. Now, the question is that what would be the distance between any 2 points in an arbitrary set? For example, if you have a set X, okay, whose elements are A, B, C, D. So, how can we say that what is the distance between A and B, B and C and A and D? How we can say that? Keep in mind, we have defined the distance. We have defined the distance. My distance was the distance traveled by car. Your distance why? Traveled by train. Okay, somebody else defined the distance traveled by the plane. So the distance is defined by us. Okay, so it is not the same. So we have a formula. Okay, for me the formula is that we are covering the distance by the car. Your formula is we are measuring the distance by the train. Okay, so we are defining the distance between two cities. Okay, how we can say that this length is your 1 meter? Because it is defined by someone that this length would be 1 meter. It could be that one can be say that this distance is 1 meter. Okay, but now because this is the standard definition of 1 meter is this one. Okay, so it is us who define the distance. We define the formula, okay, to say that the distance between 2 points, or in mathematical way we can say the distance between two elements is this thing. Now the question is that again, what is the distance between two element in an arbitrary set, whose elements are A, B, C, D. Okay, A, B, C, D are any two elements in a set. Keep in mind, I am saying that in a set. So what would be the distance? Okay, so to overcome with this one, here is you see that first we have to see that what is the fundamental truth about the distance. Okay, for example, when we say that the distance between Delhi and Hyderabad, it means that you see the distance cannot be negative. So the distance is always non-negative. Okay, so it is universal truth that the distance between any two cities or two elements or two places or two points, it is always non-negative. First, this is the universal truth. It is the fundamental about the distance. What is the second fundamental? Second fundamental is that if we take the distance from a point, say for example, instead of Delhi I am saying a point X to itself. So definitely we are not moving anywhere. We are just standing at a point. So we have not covered any distance. So distance from a point to itself must be equal to 0. Okay, and if the distance is equal to 0, then we are not moving anywhere. We are standing on the same place. So this is also one fundamental thing that the distance between 2 points is 0 if and only if these 2 points are same. Okay, or these two places or these two identities are same. The third one is that if I say that the distance from Delhi to Hyderabad is this thing. Okay, it must be same as the distance from Hyderabad to Delhi. So the distance from one point to another point is same as the distance from the latter point to the previous point. And the fourth fundamental things about the distance is that if we are going from one place to another place, okay, and then from this place to the third place. Okay, so here is you go from here to here. So this distance is always greater than if you go from this place direct to the last destination. For example, if you want to go the distance between Delhi and Hyderabad, so if you go via Bombay, if you go via Mumbai, from Delhi you go to Mumbai and then you come from Mumbai to Hyderabad, Okay, this distance is always greater than or equal to the distance between Delhi and Hyderabad. So whatever is your parameter, whether you are going by car, okay, whether you are calculating the distance by car or you calculating the distance by train or by plane, so whatever your parameters, you will see that all these parameters, you will follow the distance, follow all these parameters. So keeping in all these parameters, the French mathematician René Fréchet defined the idea of the distance on as a function. The idea of distance as a function or as a map on the set, on a non-empty set. Okay, to calculate the distance between any 2 points in an arbitrary set. Arbitrary set means that, say for example, if you have a set of sequences, okay, you have a set of sequences. The element of the set are sequences. Then how can you say the distance, what is the distance between two elements is this thing? Or what would be the distance between any two elements in the set of sequences? There is no parameter, there is no way to find, you cannot put the sequences here and the sequence here, put the scale and you can calculate. No, because these are the element of the set. Similarly, how will you calculate the distance between two continuous functions in the set of all continuous functions, real valued continuous functions defined on a closed interval AB? Okay? Because there is no other way. You will have to define the way by which you can calculate the distance between 2 points. So there should be some mechanism, there should be some rule by which we can say that the distance in an arbitrary set, the distance between any two arbitrary set is this thing. So what would be that rule? So we should think what are the fundamentals to calculate a distance. As I mentioned that the distance, to calculate the distance between any 2 points, the first one is that it is non-negative. The second one, the distance between any 2 points is same if and only if they are same. The third one is that the distance from one point A to the other point B is same as the distance from the point B to the distance from the point B to A, and the distance from the point A to a point C is always less than or equal to the distance between these 2 points if we go by another point, say for example A to B and B to C. So these are the fundamentals for a distance. So René Fréchet is a French mathematician. He used these ideas, used these fundamentals of the distance and define the distance as a function, as a map from a set to the real number. Okay, and not only this, he first introduced the concept of a metric, or metric means the distance function between two elements of a non-empty set in 19 1906 by unifying the work on function spaces by Cantor, Volterra, Arzela, Hadamard, Ascoli and others. So now the thing is that how we can define the distance? How we can define the distance between any two elements in a set? For this we should have to make a formula, and that was introduced by Frechet. So now I am going to give the idea, I am going to give the definition of a distance function, or we call it is a metric. Okay, distance function, or it is called a metric. So we define the distance in terms of a mapping. So this is, you can see that if you have a non-empty set X, okay, and then a real valued function D from X cross X to R is said to be a metric on X. Okay, so D which is a function from X cross X to R is said to be a metric on D, or a distance function on X if it satisfies the following conditions. What are the conditions? Conditions are same which I mentioned. What are these conditions? M1 is the distance dxy is greater than or equal to 0 for all xy in X. What does it mean? The meaning is that if you take X and Y, any two elements in arbitrary set X, and we are defining the distance function, okay, or the metric which is D, then dxy is greater than or equal to 0, meaning is that the distance between X and Y is non-negative. Okay, so what we are, these are the fundamentals about the distances. The second one is dxy is equal to 0 if and only if X is equal to Y. Means the distance between 2 points, okay, is same. The distance between 2 points is 0 if and only if the points are same. So the distance between X and Y is equal to 0. And dxy is equal to dyx. That is the distance between X and Y is same as the distance between Y and X. And so it is called the symmetry property. The fourth property is that dxy is less than or equal to dxz plus dzy. That is to say, if you are this is your point X, okay, here you have point Y and here you have point Z. So the distance between X and Z is always less than or equal to the distance from X to Y plus distance from Y to Z. Okay, so if a function D which satisfies these four properties, okay, then we say that this function is a metric on a non-empty set X. And the set X, the set X with the metric D is called a metric space. Okay, a set with a metric D is called a metric space. Now we will see that on every non-empty set we can define at least one metric. We will see it later. So every set, every non-empty set, you can treat it as a metric space. But you have to, of course, you can define more than one metric, as we have mentioned in our real case while considering the distance from Delhi to Hyderabad. So the distance, I was considering the distance from Delhi to Hyderabad by covering the car. You were calculating the distance by covering train and so on and so forth. So there are different ways to calculate the distance. So same as here, not only one, you can define many distance formula, distance functions on a non-empty set. But you can always define at least one, that we will see later. So here is the set X, a non-empty set X with a distance function. D is called a metric space and D is called a metric. Now, here you can see that the third d is the, you can see that d is the generalization of the distance function, and we interpret dxy as the distance function between two elements x and y of a non-empty set X. Sometimes d is also called distance function, or we, as of course we call it is a metric. Now the triangular inequality, this is known as triangular inequality, and this one is known as the symmetric property. So the triangular inequality means that the distance from one point x to the point z is always or cannot be greater than the distance via any intermediate point. So if we from here to go to this distance and then from here to this distance, so the distance between x and z, okay, is always less than or equal to the distance between x and y plus the distance between y and z. So that is the way to define. So this is the way why we can define a distance function, or we can define a metric on a non-empty set. And again, we can consider a concrete example. So when we will consider a concrete example, we can define in different ways the idea of the different distance. As we have seen, by distance covered by car, by train, and so on and so forth. So same as here is you can define a function d on arc, a real valued function, or d on arc x cross x in different ways. And all these different ways they will satisfy, and they might satisfy, or they can satisfy all these four conditions. So if they satisfy all the four conditions, it means that they are all matrices on a non-empty set X. So that is the main idea behind this one. Okay, so let's see here is the triangular inequality. We have seen that if you have a point, okay, here you say, for example, you have a point x, okay, now you have a point y is here, here you have a point z, okay, so the distance between x and y, okay, so this we call as the dxy. So distance between x and y is always less than, or let me call this is z1. So distance between dx z1 plus distance between dz1 y. Okay. Now we can also do this one in this way, that you can start from the point x to the point y. Okay, here you have point z1. Let us go. This is the point z2. So you can start from here. So this is your point dxz1, and then from here to here is dz1, z2, and then from here to here you take dz2, z2y. So the distance between dxy, so dxy is always less than or equal to dxz. It means that this distance plus this distance plus this distance. So this distance cannot be more than or greater than the sum of these distance. You can continue in this way, so that you will see that the distance between x and y, okay, thus dxy is less than or equal to dx1, means this one plus this distance, and you continue. You can take another point d3, okay, z3, and then z4, and then z5, and so on and so forth. So you will see that the distance dxy is less than or equal to the distance between the dxz1 plus dz1 z2 plus dz and y. So this way you can see that the triangular inequality can be extended for n points, that is your z1, z2, zn. Now, let us see some concrete example. As I mentioned that we must see some concrete examples of the metric. So, the very simple way, keep in mind in mathematics, always whenever you will try to find the example of anything. Okay, first you look towards the real line. This is very important. Whether real line satisfy or a real line can have this property or not. So first you look, and the easiest example, okay, you can find on the real line. The real line is the best example and the most important example. Okay, sometimes you will get that it is satisfying the property, sometimes it may not, but it is the best way to start from the real line. So, in the same way, we will start our case for to define or the examples of metric space as real line. So, let us take the x is equal to r. R means set of all real numbers. Okay, and then we define the distance on x. Keep in mind what is x? X is the set of all real numbers. So, now we define the distance as dxy is equal to mod of x minus y. Now, you see what is how we defined the distance on the real lines. You have a real line, okay, suppose this is your real line, this is your real line r, here you have say for example 0, you have any 2 point say for example x, and here you have y. So, what will be the distance? How do we calculate the distance between x and y? We calculate the distance between x and y, it is mod of x minus y. So, that is the distance between x and y. So, this is the usual. This is the usual distance. So, we can define this dxy. So, we can take this dxy. So, what is our function is dxy. So, dxy, the function d we are defining on x cross x in this way, that dxy is equal to mod of x minus y. So, we can define this dxy is equal to mod of x minus y. Then you can see that this d, function d, which is defined in this way, satisfies all the 4 properties which we mentioned. Now, you know that the property number 1, okay, m1, dxy is greater than 0, greater than or equal to 0, because mod of x minus y is greater than or equal to 0, so it is greater than or equal to 0. Now, it is very simple to say that dxy is equal to mod of x minus y, it is equal to 0 if and only if x is equal to y. So, you can see it is directly from the definition of the mod. Same as mod dxy is equal to mod of x minus y, and mod of x minus y is same as minus x minus y, which is same as mod of x minus y, and mod of x minus y minus x, and y minus x is equal to dyx. So, dxy is equal to dxy is equal to dyx. It means that the symmetric property hold. Now, take the fourth one. Fourth one is that dxy, okay, we have dxy is equal to mod of x minus y by our definition. This. So, here is now we can subtract minus x and add plus x. Okay, then we can use the property of the mod, because mod of x plus y is less than or equal to mod of x plus mod of y. Okay, so you know that the mod of x plus y is less than or equal to mod of x plus mod of y. So, by using this property, we can say that here is this is less than or equal to mod of x minus y plus mod of z minus y. But this is what? This is your dxz and this is your dzy, and therefore we see that dxy is less than or equal to dxz plus dzy. It means that this function dxy on x cross x defined by mod of x minus y satisfies all the four properties of a metric function or of a metric, and therefore this D is a metric on R. And as we have seen that this is nothing but it is the usual way to calculate the distance between any 2 point in any 2 point on R. So it is called usual metric. So it is called usual metric on R. Okay. So here similarly, in the same way, you will see that we can define the metric on the set of all complex numbers. So again, to prove that the D, if you we consider x is equal to set of all complex numbers C, and we define D, okay, on x cross x. So here we define D, D from x cross x to R plus, okay, in this way, and then because this property also holds good in the case of complex numbers, so we can see that the dxy is equal to mod of x minus y, okay, where x and y are complex numbers. This D is also satisfies all these four properties. Okay, and therefore this D is a metric on C. And again, this is the way to calculate the distance between any 2 point in the set of complex numbers. Okay, and therefore it is called usual metric on C. So that is the way to calculate the metric, to define the metric on the set of all real numbers or the set of all complex numbers. Okay, so I stop over here, and in the next lecture we will see some other examples of a metric on R or on some other non-empty sets. Thank you very much.